Good morning, everyone. I'm Mr. Florendo, your Algebra 1 teacher. Today, week 13, we will discuss about trigonometric ratios that is in chapter 10, lesson number 6, textbook pages 648 to 651. Materials needed: your textbook, notebook, and pen. Our goals: to be able to find the sine, cosine, and tangent of an acute angle, to solve problems using trigonometric ratios. Terminology: no one uses the word trigonometry. Instead, we will use the word trig. What is a trig or trigonometry? Literally, it is the measure of triangles. It is an extremely useful, practical, and powerful math tool. It is a branch of math that finds its way into practically everything we do and usually learn in high school. What you will learn: the basic terms and methods of solving right triangles, how to solve problems using trig, and what is a trigonometric ratios or a trig ratios. It is based on the sides of a right triangle. We will study only the three: the sine, cosine, and tangent. So in a right triangle, from angle A, this leg is the adjacent side. From angle A, this leg is the opposite side. From angle B, this leg is the adjacent side. And then from angle B, this leg is the opposite side. We know that the side opposite the right angle is your hypotenuse side. Let's define what's a sine function. The sine of angle A is the ratio between opposite side and hypotenuse side. The cosine of angle A is the ratio of the adjacent side and the hypotenuse side. The tangent of angle A is the ratio of opposite over adjacent side. Abbreviations: sine of angle A equals to opposite over hypotenuse side. We can read this one as sin A equals to opposite over hypotenuse. For cosine of angle A equals to adjacent over hypotenuse, or we could write this one as cos A equals to adjacent over hypotenuse. For tangent of angle A equals to opposite over adjacent, we can name this one or read tan A equals to opposite over adjacent. Memory aid: we know that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. For us to remember the definition of these three trigonometric ratios, we can use this mnemonic word. So for the sine, ka for the cosine, toa for the tangent. You can read this one as SOHCAHTOA. Example number 1, writing ratios in a right triangle. If you are asked to find the sin B, cos B, and tan B with respect to this figure, so we will have for the sin B is opposite over hypotenuse. So this is the angle B. Opposite of angle B is 4. So you will have 4 over the length of the hypotenuse of B of this right triangle is 5. Therefore, sin B equals to 4 over 5. Cos B equals to, cosine is ka. that is adjacent over hypotenuse. This is the angle. The adjacent side is this leg, that is 3. The hypotenuse is 5. Therefore, cos B equals to 3 over 5. Tangent B. Tangent B is TOA, that is opposite over adjacent side. So angle opposite is 4 and adjacent is 3. So tangent B equals to 4 over 3. What about for the angle A? For the sin A, that could be sin opposite over hypotenuse. So this is the angle A, opposite is 3, and the hypotenuse is 5. Therefore, sin A equals to 3 over 5. Cos A. Cos A is adjacent over hypotenuse. So adjacent, that is 4, hypotenuse, that is 5. Tangent A. Tangent A is TOA, opposite. Opposite is 3, adjacent is 4. So tangent A equals to 3/4. Find these values using your calculator. Take note in this example, make sure your degree mode is, the mode of your calculator must be in degree. Let's say, for example, you are asked to find the approximate value of sin 15. Check the mode of your calculator. It must be in degree. So plug this one, sin 15, that is 0.2588. Cos 45, 0.7071. Tangent 45 degrees, that is 1. Cos 80 degrees, that is 0.1736. Sin 10 degrees, 0.1736. Tangent 5 degrees, 0.0875. Cos 60, 0.5. Sin 90, that is 1. In solving triangles, first, we need to carefully analyze what given information you have. Decide what you are trying to find. Ask, how do you use the given information to solve the problem? Write an equation applying the SOHCAHTOA. Solve the given problem. Let's take a look at this example number 1. Find x in this right triangle. So the first thing that we're going to analyze here is from the angle 28 degree. X is the opposite side, the same. And 15 is the hypotenuse side. What trig ratio is this that involve opposite and hypotenuse? That could be sine. It is in the SO, OH. So now we can write the equation and then solve that one. The equation would be, since this is sin of 28 equals to opposite side, that is x, over 15. To solve for your x, cross multiply. 15 times sin 28 equals to x. Get the approximate value of sin 28, that is 15 times 0.4695 equals to x. Multiply 15 times 0.495. X therefore is approximately 7. So the value of your x in this right triangle is 7. Another example. So the same case, we need to identify the given. From angle 31 degrees, y is the adjacent. This one is the hypotenuse. So we just write the equation and then solve that one. Since from the given right triangle, it involves adjacent and hypotenuse side, so we will be using here the trigonometric ratio of cosine. Cosine 31 degrees equals to y over 56. This is now the equation out from this figure. So solving for y, cross multiply this one. 56 times cos 31 equals to 1. Get the approximate value of cos 31 degrees. That is 56 times 0.8572 equals to y. Multiply 56 times 0.8572. Y is approximately 48.0. Another example. Find A. So again, we're going to identify the given. This is the angle. So A here is the opposite, and this side or this leg is the adjacent to this angle. Write an equation and then solve this one. We have here opposite and adjacent. So trigonometric function that involve opposite and adjacent. We have tangent. So we will have tan 40 degrees equals to A over 80. Cross multiply to solve for your A. 8 times tangent 40 equals to A. Approximate value of tangent 40, that is 8 times 0.8391. Multiply the left side. A therefore is approximately 6.7. Remember, in algebra, if you have this proportion, 12 over x equals to 3. So we need only to cross multiply that one. That could be x times 3, that is 3x equals to 12. To solve for x, divide both sides by 3, and then x therefore equals to 4. Therefore, if you have a over b equals to c, is the same as a over c equals to b. Another example, if you are asked to find the value of your a, take note of the given. This is the angle. 17 is the opposite. A is the adjacent side of this angle. So what trigonometric function that involves opposite and adjacent? That is tangent. So the second step, write the equation and then solve. Since it involves tangent, so tangent 40 degrees equals to 17 over A. Cross multiply, that is A times tangent 40 equals to 17. Solving for A, just simply divide both sides by tangent 40. So we will have A equals to 17 over tangent 40 equals to 17 divided by the approximate value of tangent 40 degrees, that is 0.8391. So dividing that one, A therefore is approximately 20.3. Another example. Using this right triangle, we have the angle 78 degrees. 150 is the adjacent side with respect to this angle, and your x is the opposite side. So x and 150 degrees, that is opposite and adjacent. So we're going to use here tangent 78 equals to x over 150. To solve for your x, cross multiply that one. 150 times tangent 78 degrees equals to x. So multiplying that one, approximate value of tangent 78 degrees, 150 times tangent 78 is 4.7046. Multiplying the left side, x therefore is approximately 705.7. To solve for y, so solving for y, your y is the hypotenuse and 150 is the adjacent. Hypotenuse and adjacent, so we're going to use cosine 78 degrees equals to 150 over y. Cross multiply to solve for your y. Y therefore equals to 150 divided by cos 78, and the approximate value of cos 78, we will have 150 divided by 0.2079. Dividing that one, y is approximately 721.5. Take note that in a right triangle, the hypotenuse side is the longest side. So the value of y must be the biggest in those length of side. 721, 705, 150. So therefore, this one is verified already. Take note, right triangle. Angle of elevation. When we say the angle of elevation, let's say for example this one. This is the line of sight to this flying object. So from the horizontal line of sight of that object, the angle of elevation is formed above the horizontal line of sight. Okay? The angle of depression, This is the line of sight. The horizontal line of sight, okay? So the angle of depression is formed below the horizontal line of sight. Let's take this problem. Standing 30 yards from a tree, the angle of elevation to the top of the tree is 15 degrees. How tall is the tree? We can illustrate first the figure. Let's say we have a tree here. So the angle of elevation to the top of the tree is 15. So this is the horizontal line of sight. So this is the angle of elevation, that is 15 degrees. The unknown here is the height of the tree, but the distance from a tree is 30 yards. So we have here opposite, that is the height of the tree, and then 30 yards, which is the adjacent. So opposite and adjacent, we will be using here tangent 15 degrees equals to h over 30. Cross multiply to solve for the h. H equals to 30 times tangent 15. Find the approximate value of tangent 15. 30 times 0.2679, multiply that one. The height is approximately 8 yards already. So the height of the tree is approximately 8 yards. Summary. The trig ratios are based on acute angles in right triangles. These are the sine, cosine, tangent. You can remember the definition of this tree using the mnemonic words SOHCAHTOA. The angle of elevation is from the ground up, while the angle Naku, hindi ata na ano.